Thank you. I have a loud voice. Okay, I will speak about that. This is my name, and that is my institute. And also, I am involved in the independent. We all want to be independent. And those who are against us, they are certainly not independent. They are puppies on the string. But a committee on geoethics, because beside the scientific problems, there are also ethical problems. There are things you can say, and there are things you shouldn't say. Okay, which one is forward and backwards? Okay. I have two choices, and it's not so easy to do it correctly.
Like the bloodstream.
Yeah. You know, they say, listen to science, they say. Well, what is science? Well, what science do they refer to? Scaremongering or observational-based science? This is what we think here. This is what is triggering us. This is what is driving us. The observational-based facts. Okay, what happened here? Something move. So this paper is about science of the oceans, the ocean circulation system, and of course, the Gulf Stream is just outside our door. It will be about the Gulf Stream. The forcing, what forces are controlling it? What forces are pushing the Gulf Stream? One thing is for sure, it's not CO2. How could CO2 change Gulf Stream? But I will tell you, I cannot resist jumping into sea level. And then some ending conclusion about scaremongering. Okay. Next one. Circulation and Gulf Stream beat. Okay, the oceanic system of big streams, currents are so important, and you have the most important one. First of all, you have the equatorial, and you can see immediately one thing. It is lagging behind the rotation of the Earth. Okay? It means so if rotation changes, the current will change. As simple as that. And then you have oscillation, you have the ENSO, that's an effect of it. You have the PDO, the 60-year cycle here. The North Atlantic oscillation here. It's also 60 years. So they oscillate in the ocean. Then we have the Kuroshio and the Gulf Stream. This is the Kuroshio, this is the Gulf Stream and the Kuroshio. They take warm equatorial water up to the northwest. And of course, that changes the mass distribution, but it also affects the climate here and for us. Look here, we are sitting here. If we wouldn't have been, we would have have the conference there. We wouldn't be able to go outside the door. And it's only Eskimos and Indians which are living there. So this is an war, and that is what I will speak about. And of course, the southward Arctic flow. So when it comes down water here, it of course affects it. And the southern hemisphere, you have those which are upwelling, the coastal upwelling, that high productivity has the effect of CO2. It's extremely important, but there they are. So if you see any beat in those, and the Antarctic, which is going and sealing off Antarctica, so it plays its own life. What happened here? Oh, yeah, this one.
If you don't make it with that one, just press that one.
I love this machine. So good matter. So the Gulf Stream. We used to talk about the Gulf Stream, like it's this one huge thing. But of course, it is a northern branch and it's a southern branch. And if something happens, do you think they both increase and decrease? No, 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 no. When the northern increase, the southern decrease. So this is the way of changing the ocean. And that is important. It's fundamental, because then you go into what is controlling this system. So this also means when this is strong, this is weak. When it's warm here, we suddenly get cooling there, upside down. And then usually we feel as if we take that away and say, oh, this is in the south. They don't know what they are doing. Okay? And that's completely nonsense. Observation is observation. And who said we should stay on observation? For sure. So this is what I'm going to, and another branch which is going into the Bay of Biscay. So at solar maxima, when you have strong solar activity, not just one solar cycle, but several strong ones. That is a ground solar maximum, and we have ground solar minima. Earth slows down, and this goes to the north, and this less here. Warming here, and we get happy, they get a little depressed. Okay? And then solar minima. Arctic water comes down all the way to Lisbon. Isn't it fantastic? And this goes by, but this one increases. So it gets warm here whilst it gets cold here. I will try to speak a little about this. So we have three stages. This one, that one, which goes to the Bay of Biscay. So it's warm here, that was cool here, warm here, and then the worst thing when it's going down all the way here. And now it's a better, better drawing of the cold water. In that one, okay. And that is division. Here, ground solar maxima, ground solar minima. And so we have maxima, minima, deceleration, slower rotation, higher rotation, this and that. So we are there. Now what is driving this? So it happens so, this is something I did very long ago, 1996. So you have the rotation of the Earth. It is called length of the day, abbreviated LOD. Okay? So when it's less time, it's of course speeding up. When it's more time, it's slowing down. Okay? And this is the North European. So this is really the Gulf Stream on our side. So it's cold, warm, cold, warm. And fall in sea level, rise in sea level, and stability. Changes in the sea, changes in the ocean. In full agreement. Here you have, this period. It is a little ice age of the Maunder minimum. Then the 18th century was warm and nice, and it is ground solar maxima. And the polar and the Arctic ice was north of Svalbard, even north of where it is today. And what do we say to that? Remarkable. And then comes changes here. Cold War and fall of the sea level. It's about 30 years for those. And it corresponds to these cyclic things. Okay? And that is 60 years periodicity. So we have to understand, what is the 60 years periodicity? What is driving this? Plus and minus a little. Okay? Then we come to an interesting, that is the observed changes in the solar activity. The sun is doing two things. We're coming to that. So this is the ground solar. When it's yellow, it's ground solar maxima, and when it is blue, or on the blue side, it is cold period and it's minima, because it starts to change here. And it's built up from C14 production. C14 is a radioactive thing which we date with. But the more infall of cosmic ray, the more CO2. So if the shielding is loose, as in minima, more CO4 is produced. And if it's strong, it's less. And this is the change. Oh, if I put, what did I do? Oh, there, now back up. So here we are, this is the Viking time. And look, 100 years later, it's in the low, cold. And we will see that in the fall. And this is a big Spörer minimum, Maunder minimum, and then the small Dalton minimum. And it continues. And then at about 1950 it stops because they bomb and we have no more record of it. I have a better diagram of the same thing, where you have really how much C14 it is, and then the shielding capacity, strong or weak shielding. And this is plus, and there are less. So here it is a minimum, and more of C14. Then suddenly it switches here, because it's shielded. Less particles are falling in, and it goes, and it comes here at about 6. And something happened. It opens the system for infall of and it goes this way, poof, and then poof, it's and goes this way. And then you have, this one is of course, this is a Monde minimum, and that is the Dalton minimum, okay? This one falling there. And then you have another one up here. And then up to 1950, the bomb and the whole, we cannot work with it any longer. But here we have a fantastic system. You see, those here is a little longer, and they are so much smaller. That's what I saw in the rotation business. Didn't you see, remember, previous one? Longer in the old part and less in the new one. Just check this one, this one. This one, that one. So now we work with this industry. We have temperature record in all the red spots. Okay? And and then the diagrams are here from 1672 to 1708. Okay? Then you can see something very remarkable. Here's warm, but then it becomes cold. Here is a huge cold period. So this is the little ice age of the Monde minimum. But in the south, you have the opposite. It's a little interglacial. So how do you get this thing together? You cannot smear it up and just make a strange decoct, which doesn't say anything. Do you lose the dynamicity? So we see that. And this is then this system here into the Bay of Biscay. It's here. And then it goes back all the way down. So it's only down here in those two spots where you have this one. So this is a database. And then comes Spörer minimum, Monde minimum. All of them had this type of circulation, all the way down to Lisbon. That's quite and here it was an intensification of the southern one. So again, what I began with, you say, now we have those, this one is increasing, and the other is. That's on the ground solar maxima, and the other is this. So, then I take this one. Now we have an example of this, which you know so very well, because you went out there with the boats. We all went. And you easily, you were in Iceland and you went this way. No, there were no icebergs here. And no, you could go all the way here, no problem. In 900 to 1000, 50 years later, it's really 1050, you had to go this way. So because something had happened. And that was the changes I showed you before, from the Viking time warm period into the Oort ground solar minimum, precisely at that time. And then later it was displaced down here. And after 1450, you are in the Spörer minimum, and they couldn't even go there. And the poor people here, they died. As simple as that. Okay, then we have Oles. It will come back several times. This is wonderful. I will just tell you that this is the cold front in the 1600s. That's the Monde minimum. All the way down here. And in 18 to 1880, that is the Dalton minimum. All the way here. And things happened. Canoes with the Eskimos landed in England and Scotland and so on. So it was a fantastic... It's cold periods. That's ground solar minima. Now we go to the other period up here. Look here. 1769. It was north of Svalbard. And 1966, it was here. And 1866. So that was a ground solar maxima. And, you know, here, 1760, there were very few cars out. Yeah. Okay, then we come to something different. Oh, yeah, I think I'm totally correct in my timing. Here we have a big circulation theory. I was speaking about circulation from rotation. Okay? Oceanographers usually talk about thermohaline circulation, because haline is salinity, and depending upon water salinity, it has to change in a vertical sense. The other is wind. But this is quite interesting. You have a global system which goes over and couple into, you know this system, that is the Gulf Stream. Okay? Oh, I know this system, Gulf Stream. And then when it comes up here, it turns down. Downwelling, and goes down into a cold, because it takes with it, it pushes the Arctic water, so it goes down all over the globe. It's a global system. I have been speaking about this system. Now we will see if there are changes here, in this here, because I had these two things, okay? So if they go on there, do they affect the downwelling here? If they do so, we would see changes all over here. Jan-Erik has shown in a picture that when Perry said that it was a delay time of the signals because it's a system here. It's very interesting. But I will show you something else also. Now we couple this with what I said about the Gulf Stream. And we look at the ground solar minima, and here they are listed. And whoop, you get a whoop, what is this? The next one will come here. It's quite interesting. And then the solar minima, and you have the time. That was the Viking, and then they come, or I could have, there. After this comes, or I didn't have it. So the system here, we have, as I said, today, so we begin here. It is warm and sea level is a little high, not very much. It's just small thing. But the Gulf Stream to Gibraltar, the southern stream, it is diminished. So it's tendency of cooling and a tendency of less water masses. And there is an overturning here, overturning there. But this is plus here. Then we go to the Indian Ocean and the Pacific. What is this? Because it's a minus. It's lower sea level. And it is not little. It is 60 to 70 centimeters. And it is not a mistake, because here we have peat under the sea. Peat doesn't grow under the sea. And here we have a whole harbor and a whole building underwater. We have salt kilns where they are making salt by heating it underneath the sea. So this is a low, and we have the same thing here. So this is fantastic. It's completely opposite. It should have been high because it's a warm period, and ice, so to say, should melt. But it's the opposite here. Okay. And there are evidence. I have been working in all these places. And first, it was, of course, to my surprise. Then I traced it here. Then I went there. I got excellent idea. Fantastic thing. It's even a painting, because Goa was, the Portuguese came there in 1510. And in early 18th century, somebody made a painting. And it was a new harbor, which was lower, and above hanging, it was an old harbor. It's kind of fantastic. So lots of these things exist. Now we go to minimum. Minimum, this one decreases, and the southern branch the southern branch increases. Okay? So, therefore, it is plus here. It's warm there. And here it's become cool, and sea level is falling down a little. So, cool period like the Mont du Minot, those who are listed there. During this period, it should be low sea level, as it is here, because ice is accumulating. But look here, it's plus signs here, and it's plus signs there. It's high, and it is a question of 60, 70 centimeters. And it's not a mistake, because you have the evidence so simply there. So we have a whole system which is beating. The interesting thing now, that is I haven't even written this, but that it blocks the downwelling because there's not enough water coming here. That means that the whole of this system will beat in the same way as the Gulf Stream is beating. Isn't that fantastic? Oh, and that is a global system. But all these, may I say idiots, but I am not allowed to say that. Well, they always think that everything is the same. Poof, 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 poof. That's easy for the mind, you know. And sea level is parallel. That's something which we left in the 70s. We left. Sea is not parallel. Sea is irregular, and next sea level is irregular in the other side. Okay? And we must work with these physical realities. So, so next one. Rotation you can have from inside the Earth system, and you can have it from outside the Earth system. Inside the Earth system is, for example, during the Ice Age. When you're in Ice Age, I lower sea level by about 120 meters because ice accumulates. It means the radius is shorter, and it spins up. Physicists, they know this. And you know this, Sonja Henning. Okay. When she was spinning, you know, when she was spinning fast, she had arms here. And then when she wanted to slow down, finally slow down, delicately she put out her arms. And that was a radius. The radius, that's physics in operation. That's quite nice. So we have those, there's external and internal. And the thing is that external forcing, I propose also, it's internal, but there's also external. I proposed that 1996, and then Scafetta and somebody else have proven this. So for me, this affects the Earth's rotation. Earth is a water distribution. That's the currents I talk about. And on the circulation in the atmosphere, that is the wind pattern. The easiest one to change is, of course, the surface circulation. But all the other talked about the deep water circulation. But the deep water is, for me, a baby of this one. Okay? And then you have an ocean continental climate here, and you have sea level, also continental climate. So that is the distribution. Then a few rapid slides. During the maximum ice age, it was spinning up. Maybe it was 1,500 milliseconds faster, about. But here, then, the lagging behind increased, of course. So here, water got this way. And now comes the interesting. Both the Kuroshiya drift and the Gulf Stream, they bent down, precisely as I've been telling you before. So they bent down, and here it's affected by the ice, but here it's not in there. So it's really the rotational effect. And then you have some other stages. This was the full ice stage. They were a stage about 18,000 years ago, and then 16 to 14 years. It was broke down all the way into the Arctic Sea, and here you had a polar front. And it was, of course, warm and nice here. Directly after this, you had a so-called Younger Dryas. So polar front went all the way down here, and the Gulf Stream was. But if you went here, you couldn't see this because it got warmer, depending on what kind of marine species we're looking at. I fixed that. Now we're coming to the outer phase with the northern and southern hemisphere. And it is, of course, Euler's diagram, which is so interesting. Now we are in the young stuff. But look here, this is the high latitude, or high and high, but it is up from 55 to 65. And this is equatorial. So here in 2011, it starts to get cooler. And here at 1 year later, it starts to get warmer. Okay? That is it. That is the out of phase, which I have been talking about. But here is all of this complete. What am I doing? I didn't touch anything, but I moved here.
No, I think it's this one. It's a little complicated.
Oh, I should take that away. So
maybe, I think so.
Yeah. Okay, no, and I should take this one.
Just this one.
Oh, fine. Okay.
Down, up.
Yeah, but no, I'm not up. I'm only down. So then we come to the last page. This is, you see, the latitudes, the longitudes, and this is the Gibraltar area. Because warm here, we know about this warm, and we knew about the cooling here. Okay, but it was cool here, warm there, and cold here. Isn't that interesting? It's this out of phase, an anti-correlation between north and south is striking. And then I take an example. This is from Tenerife. You see, climate here, I should have gone there. It's stable, it's rising, it's high, it's falling. In this period, everybody knows that climate is rising. Globally, they say. And after about 40, 50, everybody knows that it goes down to 90, 70, and it's rising rapidly. And what happened here, we discussed. The pause comes there. But this is opposite. Complete. When it was supposed to be warm peak here, it started to go downwards. So here it should go down. It is rising. So it's this bulge here, it's opposite to the so-called global one. It is opposite to the northern hemisphere. Why? Why? Now you know this. Because of the change in the beat. And then this one, which should certainly for 1970, is the period of rise. Here comes then the pause. But this is again said, it is not as simple as that. We'll take another example. This is Mallorca. Okay? It's falling down here. That's exactly the time when it was supposed to rise. And this bulge is high exactly when it was supposed to be low. And this is 1970 is supposed to rise. It's not a very big rise, and it is stable. So this is the raw data from observational measurements. Okay? But what did IPCC do with this? This is what I showed. And then they had processed it. And this is what they presented. So this one is now the rise, which we all know about, and the bulge here has disappeared, and this one is completely disappeared. They handle the data by data adjustment. Data adjustment, you know. We can really see them sitting there. We need to have some data adjustment. So this is what they did. But for me, they steal the dynamicity, because the dynamicity, it was these changes. There's nothing wrong with it. But if you changed it, you don't see the things which are there, which is important. So forcing functions. Okay, now I'm off. God, I was talking too much. This is, of course, we have the sun and we have the planetary beat. Planetary beat is not just gravity. It's angular momentum, but orbital speed is the distance to the center of mass, solar distance, magnetism, etc. They affect the sun. Exactly what they are doing, we haven't really solved, but we have a project on it. Out of this comes changes in luminosity, and that is light, and solar wind, that is magnetic storms. And then it affects the sun, the Earth and the Moon, and the Earth-Moon system. And of course, that's the whole thing. So the center of mass, if all these bodies have a center where all the masses are together, if so many of the big planets are on this side, the sun has to go on this side. So what is in the center? Was in the center? First they said it's the sun, of course, but then they changed it. Aristotle and later Ptolemaeus. It is the earth, of course, because it was created like that. But and it took 1,800 years to get it back where it should be, in the sun in the center. But it's not exactly because it is the center of us which is in the center. And the other moves. And when they move, it can go to radius out of place, so far out. And of course, that affects what happens with the Earth very much. So these changes are interesting. Now you have Jupiter and Saturn. The motion of Jupiter and Saturn, boo-boo, 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 has a cyclicity of, no, that is 60 years, the two together. Have I said something about the 60 years before? No. So that means that a 60-year cycle, this is what we see. And I mean, doesn't matter, it is impossible by changing the CO2 emission to change the speed of the planets. So we have this planetary beat. This is what I talked about on the sun. And out comes luminosity and solar wind, or irradiance is all. This luminosity, irradiance is the same word. So we have a variation in the solar activity, due to the beat here. And that changes the light and the solar wind. And the solar wind is interesting because it affects the controls totally the shielding. And the shielding is how much cosmic ray is coming in. And they affect how much C14 and how much beryllium-10 is being produced. So we can read the shielding from reading this. And according to Svensbach, the cloud formation is essential here. And then the Earth's rotation is. So we have this, and this line of affecting the Earth. So then we talked about the planetary. Now we make it a little more complicated. Effects is going to the sun. Sun is emitting luminosity and solar wind. Solar wind, they have talked so much about this. I added these things. And it goes to the Earth-Moon system and in between. So the shielding, geomagnetism, pressure, gravity, rotation, ocean circulation. This is what I've been talking. Wind circulation. Corbyn is doing his fantastic predictions of climate with this. And the cloud formation, that's the Svensbach, and we can say really soon, and also Father and Son and the Holy Spirit here, talking about the total irradiance. But that affects the terrestrial changes in climate. Then we can go, we can go one way. So if you have the solar wind, is here. This is what you read and what you see. So many of these parameters, you see them here in the Earth-Moon system also. So then you can be sure if these for example, geomagnetism has a 60-year cycle. How can a 60-year cycle in the magnetic occur if it is not at the same time as ocean things and sea level change? Only if it goes this way. And then we go back now to what we saw about the Gulf Stream. The Gulf, now we take the C14 curve, how much you have and how little. So when you have it low, it's solar minima, and you have a lot of particles falling in its upside. This scale is not that. So that is a solar wind curve in some way. Okay? And all the time it was high, you had the Gulf Stream, the northern branch with solar maxima. And here, Spörer, Maunder, Dalton, and now comes it. The future is this way. So there is some sort of cyclicity in here. So at about 2030, 2040, we are supposed to be back in one of those. And of course, this is exactly, then close up of it. This will be repeated at the next grand solar maximum in And that is about. I can calculate the difference. But it's coming in this century. And when it's getting cold here, it's getting warmer here. So warm winds and a new little ice age. But is it as severe as the Dalton minimum or the Maunder minimum? We don't know. Abdur Ramazov, which I work with, he says it's a Maunder minimum. I think we are more moderate, we say probably a Dalton. 5, thank you. So we have now the so-called global temperature, this OLUS. So puff up, down, up, down, up, down. And this is exactly as much as this one. This is the one which is supposed to be driven CO2. Okay, if that is driven, what is this driven? It's not very many cars that. And why is it 60 years cyclicity? Okay. And the true forcing function goes via solar variability, geomagnetic shielding, Earth rotation, Gulf Stream beat, ocean oscillation, jet stream variation, and cloud formation. This is what I showed you before. All ultimately driven by the Jupiter-Saturn beat, which of course operate regardless of CO2 emission, and the Sun and the Earth-Moon system. So this is what we are dealing with. Global sea level. Wow. So this is just that it was a high here in the morning, it was a low there, there was temple, a lot of things. Yeah. I have to go, I'm a little off. And this is the same thing as I'm talking. It's going up there, high here, but it's low there. And then when solar maxima, this comes down, it's cold here, but here it's cold. And here we should be low, but we have plus. It's really remarkable. And then this is the equatorial curve. And today, it's stable, plus minus. And here is the northwest. It's small oscillations here. It's not very big, it's small oscillations. But the rate here is 1.1 millimeter per year, nothing else. And here comes the diagram, because here you see the northern is 30 degrees. Low, high, high, low, high, low, and here there may be synchronization, meaning that really ice was disappearing. And then you have a low there, high there, low there. And it means in the future this will go down and this will go up. But this is affected. And this is the difference, the equatorial water bulge and the rate of rotation. So it was when it is a low letter, it is, and that was in 1750, and this is 1650. It's quite fantastic, a new record, never known before. And of course, the only way to understand that these things go down, change the gravity, rotation, wind, and so that is changing the ocean circulation. And we know that, we can tell, because here, we know that the shielding effect changed. We know that the geomagnetic, it's measured, and this is the integrated system of it. That's what I've been talking about. So for scaremongering, of course, the nonsense is nonsense, despite endorsed by UNEP, Guterres, Greta, and other AGV opponents, proponents. Listen to science, they say, but their science is not our science, just lobbying products for IPCC AGV and simple scaremongering. For example, this is 2002. It has not even started to rise over the feet of it. So we have Don Quixote. Don Quixote, he was fighting with, he fought an illusion, but of course he was a nice and honest and noble person, but completely nuts. UNEP, IPCC, Guterres, Greta, and others are in no way better than Don Quixote, all being obsessed by an illusion. Puff, 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 puff. And here they come. Don Quixote. Ladies and gentlemen, conclusions. Conclusion is really, we will soon be in this here, and sea level, generally speaking, is in by 2001. It's about this 5 centimeter plus with an uncertainty of 15 centimeter. It's not a meter. It's not five decimeters. and you carry the Gulf Stream beat is a function of the planetary beat. Sea level is not in a rapid way. There is not a single point on Earth's surface where we have recorded an acceleration in sea. They talk and talk and talk and talk and talk, and in geoetic principle, going down and down and down. But there is not. If you look at sites which might be, you immediately see there is some other explanation which is better. And the 60-year cycle, and let us forget the trouble about CO2, which has no effect on ocean circulation, no effect on sea level, small to negligible, and now I am very kind, effect on temperature. Thank you very much.